Hello, this is question 8 on your June 2018 paper from Edexcel, the AES paper, and you have a lorry is driven between London and Newcastle. In a simple model, the cost of the journey in pounds when the lorry is driven on a steady speed of v kilometers per hour is this expression here. Find, according to the model, the value of v that minimizes the cost of the journey. So we are going to differentiate. We have only one variable, which is v. So we are going to differentiate c with respect to v. I can write the expression as v minus 1, so you know how to differentiate it, plus 60. So when we differentiate this, 1 minus 1 times 1,500, v goes down by 1, so minus 2, and then 2 over 11. Yeah, that's my derivative. I'm going to make this equal to 0, which means I have just writing one side, v squared is going to be 2 over 11. Yeah, so this one the other side, and I'm going to bring this back to the denominator because I think it's clearer to solve it. Then I can say that v squared is going to be 1,500 divided by 2 and times by 11, which is 8,250. So that means that v, when I do the square root of that value, is 90.829 kilometers per hour. So I'm going to round, I think, 3 significant figures, for example, although for the velocity probably would be just okay to say 91 kilometers per hour. You cannot see more than that in a car. Let's say this one, kilometers per hour to one decimal place. Oh, 3 significant figures. 3 significant figures. You should check that this is a minimum, but they are asking you that in the second part of the question. So they prove by using the second derivative that the cost is minimized. If they don't ask you this as a second question, I would do it here. Yeah, so you have to be sure that this value is minimizing the cost and not maximizing it. Yeah, you know it's a stationary point, but you don't know necessarily it's a minimum. So if this is not asked, I would do here. Yeah, I would do the second derivative and check that this is giving me a minimum. And now they say find the minimum cost of the journey. So I know the cost is given by this expression when I have v. So what I'm going to do is substitute this v here to find the cost. So this is the first part, I, and for the second part, I'm going to do the cost is 1,500 divided by v, so divided by 90.8 plus 2 times v divided by 11 plus 60. And to do this, I would keep all the decimals in the calculator when I substitute here, just using ands, and you have 93.028 pounds. And if we round, we can say 93.03 or just 93 pounds. Yeah. To do decimal places because it's money, so you shouldn't round to anything else unless they tell you. Then prove by using the second derivative that the cost is minimum. It's a minimum and not a maximum. So we are going to differentiate again the expression. So second derivative, I have the first derivative, so if I differentiate again, I have minus 2 times minus 1,500 is positive 3,000. V goes down by 1 again, and this one is 0. When I substitute v by 90.8, which is a positive value, I'm going to have, it doesn't matter even what you get, it's going to be positive. Yeah, you can find the value or not, because this is positive and this is positive, and if it's positive, that means it's a minimum. Yeah, therefore it's a minimum. Then C, state one limitation of the model. So this model is assuming that this lorry is traveling from London to Newcastle, just keeping the same speed. Yeah, which is a bit crazy. So it's unrealistic. It's to keep constant velocity all the way. Constant V from London to Newcastle. Yeah, and that's all with this question.